For question 4, let's start by finding an upper approximation. And we're looking for the area under the curve f of x between 0 and 20. And I'm going to decide that delta x is equal to 4 because it's kind of convenient. And I'm going to draw some rectangles. So if we're looking for, let's start with an upper approximation. For an upper approximation for each subinterval that I'm going to have here, well, I'm going to use the right-hand side because it's higher. So for my upper approximation, I'll have delta x, which is 4, times, let's see, I'm going to have 2, I'm going to call that 3, I'm going to call that 3.5, I'm going to call this 4, and then I'm going to have, I don't know, maybe 4.3. Okay, for my lower, I'm going to have the same delta x, so 4, but over here I'm going to start at, let's see, my left-hand side, I don't know, maybe that's 0.3, and then my left-hand side for this is going to be, well, the 2 I had earlier, and then the 3, and then the 3.5, and then the 4, but I'm just not going to use the 4.3. So then I can just add these up, right? So I have 2 plus 3 plus 3.5. So my upper approximation is 67.2. My lower approximation is going to be all of that. I'm going to get rid of that 4.3 and make that as 0.3 times 4. My lower approximation is I get 51.2. So if I was going to write an inequality, what I could say is the area would be less than 67.2 and greater than 51.2. And if I had to use inscribed rectangles, incidentally, inscribed, if you remember, inscribed in geometry was something that fit inside of a circle. So inscribed would look something like this, right? Inscribed would be these rectangles, which in this particular case would give us a left-hand approximation.